All right, this traffic flow problem. It says cars arrive randomly at an intersection with an average rate of 30 cars per hour. Highway engineers estimate the likelihood or probability that at least one car will enter the intersection within a period of time of X minutes is modeled by this equation. So let's write that down a little bit bigger. So f of x equals 1 minus e to the negative 0.5x. And there's our citations of where the study was from. They asked me to evaluate what f of 2 is and then interpret it. So what is f of 2? So that's 1 minus e to the negative 0.5 times 2. Again, we can grab the calculator on this one. So let's get over there and let's type it in there. So clear the screen there. We have 1 minus second ln gives me the e, negative 0.5 times 2. And that tells me that I have 0.6321. So there is again, this is the probability. That is a probability. That's what that answer represents, a probability based on the structure up above, probability. So there is a 63.21% chance that at least one car enters the intersection within 2 minutes or in 2 minutes. Okay. So there's a 63% chance that in 2 minutes at least one car is going to go into that intersection. That's what that's saying. That's a pretty big percentage. So that lets us know that's a pretty busy intersection or intersection. If I look at a clock or a watch and say, okay, time, there's a 63% chance that a car is going to enter within 2 minutes, is what that's saying. The next part says they want you to graph it, and they ask what is the likelihood for at least one car that will enter the intersection during a 60-minute period. Okay, so they asked us to graph. They didn't ask us to plug it in. So let's go to the graph. So y equals, and then we're going to type in 1 minus second ln, and then it's negative 0.5, and then it's just an x. It just wants us to graph it. And then I'm going to hit graph. All right. Okay, let's see that graph. And so now I'm supposed to say, okay, 1 minute. At least one car in 60 minutes. And so at least one car. So as I can zoom in, as I look at the table, I'll notice as X is minutes, and I scroll down the column here, at 10 minutes, there's a 99% chance that within 10 minutes, somebody enters the intersection. 13 minutes of getting closer to, and keep going. And notice as I keep going up, even here at 17 minutes, there's a 99.98% chance at least one car will have entered that intersection. Within 17 minutes, almost 100%. There's 0.999. And as we keep going, it's just going to, now notice it goes to 1, because 1, we'd only have it rounding out to so many decimal places in that column. But so by the time we get to 60 minutes, it's going to happen. All right. So what is the likelihood? We would say that there is a 100% chance or probability at least one car will enter the intersection within 60 minutes. Now, the one thing, if we go back to the graph picture, we'll notice that kind of flattens out. It actually, as we look at the picture and it comes up here, it flattens out and approaches 1 there. So we technically have a horizontal asymptote here, connecting something we did earlier in the chapter. Horizontal asymptote. at y is equal to 1. And again, if we kept scrolling on the table, we would realize that it does not go above that. It just keeps getting closer and closer to 1. And if I put out more decimal places on this calculator screen for it to go out to, then we would see that it would just keep being 0.9999999 as we keep going.